Welcome to Isoclima's AIA Continuing Education series. In this course, we'll explore how advanced security glazing can help create safer educational spaces while maintaining open and welcoming environments. Today's course is titled Securing Educational Spaces with Advanced Security Glazing. It is approved by the AIA for 1 Health, Safety, and Welfare Learning Unit. Isoclima's history spans decades of expertise in specialty glass. From its roots with D. Lubac Studios in 1947 to global leadership today, Isoclima has continuously advanced glazing technologies to meet evolving safety and security needs. Today, Isoclima is recognized worldwide as a leader in high-performance security glazing. Our solutions combine innovation, versatility, and proven performance to address a wide range of industry challenges. Isoclima offers a wide range of security glazing solutions designed for different threats, from forced entry and ballistics to blast resistance and acoustic security. These solutions ensure protection across various environments while maintaining functionality. Our glazing systems are applied across many critical spaces: schools, detention centers, courthouses, hospitals, and more, where safety, security, and performance are essential. This course is registered with AIA and is AIA approved and provides 1 Health, Safety, and Welfare Learning Unit. At the end, you'll take a short test to receive credit and a certificate of completion. Before we begin, a reminder that this presentation is protected under U.S. and international copyright law. The content may not be reproduced or distributed without written permission. This course focuses on the role of advanced security glazing in protecting schools and universities. We'll cover key standards, testing procedures, material options, and real-world case studies to show how properly specified glazing systems improve both safety and transparency. By the end of this course, you'll know how to identify security risks, differentiate between safety and security glazing, evaluate material options, and apply best practices in design integration. Section 1 sets the stage. First, we'll look at how school security risks have evolved, from after-hours break-ins and vandalism to targeted high-consequence events, and where those risks meet glass. Main entries and vestibules, classroom door lights and sidelights, and ground-level windows. Second, we'll connect glazing to threat response. The goal isn't unbreakable, it's time. We'll discuss how the right glazing and framing keep an opening intact under repeated impact so a lockdown can start and help can arrive, and why performance depends on the complete assembly: glass, frame, and anchorage. Third, we'll clarify glazing types. We'll distinguish code-required safety glazing, tempered or basic laminated for accidental impact, from security glazing engineered to resist deliberate attack. We'll outline where each belongs: forced entry laminates for doors and sidelights, glass-clad polycarbonate where ballistic risks are considered, and what retrofit options, like films or overlays, can and cannot do. As we go, keep 2 principles in mind. First, delay is protection. Even 30 to 180 seconds can make the difference between a contained incident and a tragedy. Second, performance isn't just about the glass. It's the entire system: glazing, frame, and anchorage, tested together to recognize standards. Here's a threat snapshot. Most incidents start as a forced entry or timed attack with simple hand tools: hammers, crowbars, aimed at a door light, side light, or ground floor window to get through fast. Burglary or vandalism is typically after hours, where a smash and grab with speed is the strategy and glass is the weak link. In the highest risk events, we see gunfire first, followed by a physical attempt to pry, kick, or pull the opening apart. And while blast events are rare in schools, the primary hazard is flying shards. Laminated makeups with proper retention greatly reduce that risk and help the glass stay captured in the frame. Glass is the fastest way in. You want to specify tested systems that stay in place under attack, even after shots. The goal isn't unbreakable, It's time. Let's take a closer look at how school security risks have evolved over time. Not long ago, safety planning in schools was almost entirely about accidents and fire drills, but today, architects and administrators are addressing very different realities. Tragic events, from Columbine to Sandy Hook to Uvalde, have forced security to the forefront of school design. In each of these incidents, glass has played a critical role. Entry doors, sidelights, and classroom windows, features that are essential for openness and daylight, are often the first points of attack. A single blow can turn those openings into a pathway for intrusion. That shift has changed how we design. Understanding the evolving threat landscape is the foundation for choosing glazing solutions that don't just look right, but actively protect students and staff by delaying entry and buying precious time. School safety used to be centered almost entirely on fire drills and accident prevention. That was the primary lens for designing learning environments for decades. But over time, tragic events like Columbine, Sandy Hook, and Uvalde reshaped those expectations. Each one revealed how vulnerable schools can be when glass at entrances, classroom doors, and ground-level windows isn't designed to resist intrusion. Think of it as a timeline of shifting priorities. We began with fire drills as the main safety exercise. Then Columbine in 1999 showed the world that schools could be deliberate targets. Sandy Hook in 2012 underscored just how critical glass and entryways can be in determining outcomes. Uvalde in 2022 reminded us again how quickly intruders can exploit those weaknesses. And today, we recognize that security design is a professional obligation, as critical as fire safety, accessibility, or energy performance. For architects and designers, this means safety isn't just a program element, it's a responsibility. Clients, parents, and communities expect schools to balance openness and daylight with real protective strategies. That responsibility falls to us in how we specify, design, and integrate security glazing systems. When we think about school security, doors and windows matter more than any other building element. They are the key access points, the places people naturally enter and exit, but also the areas most often targeted in an attempted intrusion. In most cases, attackers don't come prepared with high-tech tools. A rock, a hammer, or a crowbar is often enough to breach conventional glazing. That's why glass is almost always the first point of attack. At the same time, we can't overlook what doors and windows contribute to the learning environment. Students and teachers need daylight, visual connection, and transparency. The design challenge is finding the right balance between visibility and protection, providing openness during normal use, but real resistance when under threat. This is where security glazing becomes a critical design tool. It allows us to preserve openness while transforming vulnerable points of entry into protective barriers that delay intruders and protect lives. Here's a real-world example. At a Midwestern elementary school, a safety audit found that the front entry doors had tempered glass sidelights. When they tested those sidelights, they failed instantly. Just one hammer strike was enough to give an intruder immediate access. Instead of replacing the entire entrance system, the district decided to retrofit the glass with laminated security glazing that fit right into the existing frames. When they ran follow-up drills, the difference was dramatic. The glass that once shattered immediately now held together through repeated impacts for more than 3 minutes. That extra time gave staff the chance to start lockdown procedures and alert law enforcement. The takeaway is simple. Even small upgrades to vulnerable entry points can make a huge difference in safety. Security glazing doesn't just change how the glass performs, it changes the timeline. And in an emergency, that timeline can save lives. K-12 schools and universities face a wide range of threats today. At one end of the spectrum are after-hours break-ins, vandalism, and theft. These are unfortunately common, and they target the glass at entries or storefronts because it's the quickest way in. Then there are domestic disputes or active shooter incidents, which represent the highest risk situations. In these events, glass is almost always the first barrier tested. through impact or gunfire. We also can't overlook civil unrest or severe weather events. A storm, hurricane, or even high winds can turn glazing into a hazard if it isn't properly designed. And each of these threats presents a different challenge for building safety, but they all share a common factor. Glass is usually the first target and often the fastest way inside. That's why glazing design is such a critical piece of school security. In most cases, attackers don't use high-tech tools. A rock, a hammer, or any heavy object is usually enough. And with standard glass, once it breaks, access is almost immediate. A locked door doesn't mean much if the glass right next to it can be shattered in seconds. The goal of security glazing isn't to make a building impenetrable. That's not realistic. The goal is to delay entry long enough for help to arrive. Even 30 seconds to a few minutes can be the difference between an incident that's contained and one that becomes a tragedy. And that's why it's important to understand the difference between glass that's only designed for life safety and glass that's designed for security. Security glazing isn't just about strength, it's about time. With standard glass, an intruder can gain entry in as little as 10 to 30 seconds. With security glazing, that delay stretches to 3 to 5 minutes. Now compare that to the average police response, which is typically 5 to 10 minutes. That gap is everything. Even a 30-second delay can mean the difference between a tragedy and a contained event. Let's take a look at this short video clip. It shows just how quickly standard glass can be broken, and how much longer security glazing can hold, even under repeated attack. So far, we've looked at the threats schools face and why time is such a critical factor in safety. Now let's turn our attention to glazing itself and the role it plays in threat response. Glass isn't just a material you see through. In a security event, it becomes a barrier that either fails in seconds or holds long enough to change the outcome. In the next slides, we'll break down the differences between safety glass and security glass and explore how tested glazing systems are designed to resist real-world attacks. And understanding that difference between life safety glazing and security glazing is the first step. This brings us to a key distinction that's often misunderstood: life safety glazing versus security glazing. Both play important roles, but they solve very different problems. Life safety glazing, like tempered or laminated glass required by code, is designed to protect people from accidental impact. If someone falls into a door or a window, the glass is meant to break safely so it doesn't cause serious injury. Security glazing, on the other hand, is designed for deliberate attack resistance. It's not about accidents. It's about stopping someone who is trying to force their way in with tools or even with gunfire. Here's the bottom line: not all glass is created equal. Meeting the building code for life safety does not mean a school is protected against forced entry. That's why it's so important to understand and specify glazing systems that are tested for true security performance. Building codes mandate the use of safety glazing in certain areas where people might accidentally come into contact with glass. That includes doors, sidelights, and low glazing. The purpose here is to prevent serious injury if the glass breaks. Safety glazing must meet standards like ANSI Z 97.1 and CPSC 16 CFR 1201, which define how the glass should break safely into small pieces or remain laminated, rather than creating dangerous shards. It's important to note that these requirements are about accidents, not about stopping a deliberate attack. A code-compliant safety glazing installation meets the building code, but it does not necessarily provide forced entry resistance. And that brings us to the next step, when we need glazing that goes beyond basic safety requirements and is tested for true security performance. Tempered glass is one of the most common types of safety glazing used in schools and public buildings. It's heat-treated for extra strength compared to ordinary glass. And when it does break, it shatters into small, blunt fragments, which helps reduce the risk of serious injury. That makes it effective for life safety, but it offers no protection against deliberate attack. With just 1 or 2 strikes from a rock or hammer, tempered glass can be broken out completely, allowing immediate access. So while tempered glass meets the building code for safety, it does not provide intrusion resistance. Laminated glass is made by bonding two layers of glass together with a plastic interlayer, usually PVB. When it breaks, the glass cracks, but the interlayer holds the pieces in place. That's why laminated glass is often used for safety. It reduces the risk of injury and prevents shards from falling out. But it's important to note that laminated glass, on its own, is not designed for security. Unless it's specifically tested and rated, it provides only minimal resistance to forced entry. A determined attacker with simple tools can still break through. So while laminated glass improves safety and is a step above tempered glass, it's not a substitute for true security glazing systems. Security glazing goes well beyond what the building code requires. These systems are engineered and tested to withstand repeated impacts, whether from hand tools, blunt force, or even ballistic threats, depending on the standard. The key difference is that the glass may crack, but it stays in place. It resists access and buys critical time during an emergency. Most security glazing is built with thicker glass layers and durable interlayers, and many systems also incorporate materials like polycarbonate for added toughness. While it isn't currently mandated by code, security glazing is highly recommended for vulnerable areas in schools because it changes the outcome by delaying entry and protecting students and staff. Security glazing isn't just a stronger piece of glass. It's a system that's been tested to perform against real-world threats. These products are evaluated under voluntary performance standards. The testing simulates what happens during an actual attack: repeated blows with sledgehammers, strikes with heavy tools, and in some cases, even firearm simulations. The goal is not to create glass that never breaks. In fact, security glazing will usually crack under impact, but the critical difference is that the glass stays in place and keeps the opening intact, resisting entry long enough to matter. The focus is always on delaying access, not necessarily stopping bullets in every case. That delay is what gives staff time to react and first responders time to arrive. There are several types of glazing systems used in schools today, each offering different levels of protection depending on the threat. The first is laminated security glass. This looks similar to standard laminated glass, but it's built with stronger interlayers and thicker glass plies, and it's tested for forced entry resistance. Next is glass-clad polycarbonate. This combines the hardness of glass with the toughness of polycarbonate, making it one of the most durable options for resisting repeated impacts. And finally, there are retrofit shields and security films. These can be applied to existing glazing to improve performance, although their level of resistance is usually lower compared to full security glass or polycarbonate systems. Each of these options plays a role, and the right choice depends on the school's risk profile, budget, and design priorities. In schools today, security glazing plays a critical role in protecting vulnerable openings. These systems are tested against forced entry and active shooter scenarios to ensure they can hold up under repeated attack. From the architect's perspective, one of the advantages is that they look and install just like conventional glass. That means we can design spaces with natural daylight and openness without sacrificing protection. And most importantly, this type of glazing is designed to remain intact after multiple blows. It may crack, but it won't fall out of the frame or create a breach. That delay is what buys time for staff to respond and for law enforcement to arrive. In this project, a school district identified its cafeteria and main entry doors as vulnerable points during a safety audit. The existing glazing met code for life safety, but offered no resistance against forced entry. The district chose to retrofit these openings with tested security glazing. In drills conducted after installation, the glass was struck repeatedly, but it remained intact and prevented access. That gave staff the time they needed to initiate lockdown procedures. What's important is that the architectural intent wasn't lost. The cafeteria remained open and filled with daylight, creating the same welcoming environment, but now with a much higher level of protection. This project shows how schools can balance security, safety, and design priorities when choosing glazing solutions. For areas of a school that face elevated risks, glass-clad polycarbonate offers even greater resilience. This material combines the clarity and hardness of glass with the toughness of polycarbonate. The result is a glazing system that can resist repeated attack and, in some cases, even ballistic threats. Because of its weight and thickness, it's most often specified in high-risk locations, like entry vestibules or administrative offices, where delaying or stopping an intruder is critical. It does come at a higher cost, but with that cost comes a higher level of protection. And in the right applications, that balance of performance and security makes it a strong design choice. For schools that aren't able to fully replace their glazing systems, retrofit options like security films or overlay shields can provide a budget-friendly way to add some level of protection. These solutions can hold glass fragments together and may add a brief delay during a forced entry attempt. But it's important to be clear, they are not the same as fully rated security glazing. Retrofit films and shields are best thought of as a stopgap measure. Better than nothing, but not a replacement for glazing that has been specifically tested and certified for attack resistance. And that brings us to the bigger picture: how security glazing is integrated into the overall design strategy for schools, where it works best, and how it complements other protective measures. Let's bring everything together with a simple example. Imagine a classroom door with a small vision panel. If that glass is tempered, a single strike will shatter it immediately, giving an intruder instant access. If it's laminated, the glass will crack and stay in place for a short time. That buys a brief delay, but it may only be seconds. But if the panel is made with tested security glazing, it can resist dozens of blows. The glass may fracture, but it stays intact and continues to protect the opening. That difference in performance isn't abstract. It's the difference between an intruder entering a classroom right away versus buying the critical time needed to move students to safety and call for help. And in real-world situations, that extra time can mean lives saved. One of the most important things to understand is that security doesn't mean sacrificing design. Today's advanced glazing solutions allow us to bring in daylight, maintain aesthetics, and meet performance goals, all while enhancing safety. Security glazing supports all three. It combines clarity and transparency with real protection, so architects don't have to choose between creating an inviting learning environment and protecting the students inside. The result is a system that delivers the best of both worlds: design freedom and peace of mind. Let's wrap up Section 1 with a quick summary of why testing matters so much. First, testing validates real-world performance. It proves that a glazing system can handle the actual threats it was designed for. Second, different tests address different types of threats. Forced entry, burglary, ballistic, and blast testing all serve unique purposes, and no single test covers everything. Third, system integrity is just as important as glass strength. It's not enough for the glass alone to resist impact. The frame, anchoring, and connections all have to hold together. Finally, performance must match the project's risk level. A suburban school doesn't need the same protection as an embassy or a government facility, but every building requires the right balance of safety and practicality. Now that we've looked at the different types of threats schools face and the glazing options available, let's move into Section 2, the importance of testing in security glazing. This is where theory meets reality. We'll talk about why standardized testing is essential, what those tests look like, and how they simulate real-world attacks, from forced entry attempts to ballistic and even blast events. The point is simple. In high-stakes environments like schools and public buildings, performance on paper doesn't matter if it doesn't hold up under pressure. Testing is what proves that glazing systems can actually do their job when it counts. When it comes to security glazing, standards are what separate marketing claims from proven performance. These standards are developed by independent organizations to create a common set of benchmarks. They define how products are tested, what kind of threats they are expected to resist, and how performance is measured. For architects and designers, standards provide a way to evaluate products on an equal footing. Instead of relying on vague descriptions, You can look to published test results and certifications that show how a glazing system performs under forced entry, ballistic, or blast scenarios. In this section, we'll look at some of the most widely used security glazing standards and how they apply specifically to schools and educational facilities. Security glazing is only as good as its performance during an actual threat. You could install the thickest glass in the world, but if it shatters or pops out of the frame on impact, it fails. That's where standardized testing becomes essential. It verifies how a glazing system will actually perform under pressure, not just the glass itself, but the frame, the anchoring, and the entire assembly working together. For architects, specifiers, and facility managers, this testing provides confidence. It takes the guesswork out of product selection by showing exactly how the system will behave when subjected to real-world attacks. In other words, testing turns a claim into a proven performance. There are several categories of security glazing tests, each simulating a different kind of real-world threat. The most common include forced entry and timed attack testing, burglary resistance, ballistic resistance, active shooter simulations, and blast resistance. Each of these tests helps specifiers match the right glazing solution to the specific risks their project faces. For example, the level of protection needed at a school entry vestibule might be very different than what's required at a courthouse or a transit hub. In the next few slides, we'll walk through these tests one by one to see how they work and what they tell us about system performance. Forced entry and timed attack testing is designed to measure how long it takes someone to breach a window or door using simple tools, things like hammers, crowbars, or screwdrivers. The goal isn't to make the glass indestructible. It's to delay an intruder long enough for help to arrive, or for a lockdown to be initiated. In school safety programs, that delay can be the critical factor. Even 30 seconds can mean the difference between danger and safety. By slowing down an attacker, security glazing buys valuable time for teachers, staff, and first responders to act. That's why this type of testing has become one of the most common standards applied to school facilities today. When we talk about forced entry and burglary resistance, two of the most widely used standards are ASTM F1233 and UL 972. ASTM F1233 is designed to evaluate the performance of security glazing materials and complete systems. It uses structured tool attacks, applied in timed cycles, to simulate break-in attempts. The focus here is forced entry resistance. UL 972, on the other hand, is more specific. It measures how well glass resists burglary-style attacks, scenarios where simple hand tools are used to gain access. What's important to remember is that both standards don't just evaluate the glass. They measure the entire assembly, the glass, the frame, and the anchoring, because all three have to work together to maintain integrity under attack. One of the most important things to understand is that these tests don't just evaluate the glass. They evaluate the entire system. That includes the glass, the frame, the anchoring hardware, and how everything works together under stress. If even one part fails, for example, if the frame gives way or the anchors pull out, the whole system fails, no matter how strong the glass is. That's why successful security design is about integration, not just material strength. The weakest link determines the outcome, and true success comes from ensuring every component is working as one. Some organizations go beyond the standard ASTM and UL tests. One of the most respected is H.P. White Laboratory. Their approach simulates real-world intrusion attempts in phases, starting with lighter tools and escalating to more aggressive impacts. This gives us a much clearer picture of how a glazing system performs under sustained pressure. That's why H.P. White's methods are widely respected in high-stakes environments like schools, embassies, and correctional facilities. It's about pushing systems past the minimum, so we know how they'll hold up when lives are on the line. Another advanced approach is the WMFL protocol. Unlike standard pass or fail impact tests, this method simulates a determined, multi-step intrusion attempt. A sequence of rapid strikes is followed by penetration attempts to see not just if the glass breaks, but whether the system holds together under sustained pressure. WMFL testing measures residual openings and overall structural integrity, which tells us if the system will still keep an intruder out after repeated blows. That makes it especially valuable for schools, police stations, and government facilities where threats can escalate quickly and unpredictably. Another important category of testing is burglary resistance. These are the smash and grab scenarios we often see in retail or commercial settings. The intruder's goal isn't necessarily prolonged access, it's speed. Break the glass, grab valuables, and escape before law enforcement arrives. Here, laminated glass plays a key role. Even when it cracks, the interlayer holds the pieces together, slowing down entry and buying precious time. Standards such as EN 1627 and UL 972 provide a measurable way to evaluate how glazing performs in these situations. For schools and public spaces, it's not always about a sophisticated attack. Sometimes, it's the opportunistic ones we have to guard against. EN 1627 is a European standard that measures resistance to manual burglary attacks, while UL 972 is more common in North America. Both focus on how well glazing systems perform against tools like hammers, chisels, and screwdrivers. These tests help specifiers and owners choose the right products for retail, office, or commercial spaces, where burglary protection is key. Ballistic resistance takes protection to the next level. These tests measure how glazing performs when struck by bullets, whether from handguns, shotguns, or rifles. The goal isn't just to stop the glass from breaking, but to prevent bullets from penetrating through to the other side. Two of the most widely used standards here are UL 752 and NIJ 0108.01. Both outline multiple threat levels depending on the weapon type, caliber, and the number of shots fired. For example, a glazing system may resist small handguns at one level, but higher levels simulate powerful rifles with repeated rounds. Understanding these ratings is essential, especially in environments where firearm threats are a real possibility. Now that we've compared UL 752 and NIJ 0108.01 and where they're typically applied, let's take a closer look at how these standards are tested in real-world conditions and what they mean for specifying security glazing in different environments. UL 752 is widely used for commercial, public, and general safety applications, places like banks, offices, and schools. NIJ 0108.01, developed by the National Institute of Justice, is more commonly required for law enforcement and military environments. It addresses additional law enforcement-specific threats and is often a requirement when working with government clients. Both standards evaluate ballistic resistance, but the environments they serve are very different. So, when specifying glazing, it's essential to align the standard with the project's security needs. Of course, just because glass can stop a bullet doesn't mean the job is done. Let's look at why ballistic resistance alone isn't enough to ensure real protection. Stopping a bullet is only part of the equation. A glazing system hasn't succeeded just because the bullet didn't pass through. If the glass breaks out of the frame after impact, the opening is still vulnerable, and an intruder can simply step right in. That's why in schools, offices, or public spaces, ballistic resistance must also mean structural integrity. The glass has to stay anchored in place, even after repeated hits. Real-world protection means two things. First, stopping the bullet, and second, continuing to delay forced entry. Only then does the system truly serve its purpose. And this brings us to an even more critical question. How do these systems perform under the most extreme, real-world threats, like active shooter scenarios? Let's take a look. Active shooter simulations take testing even further. These aren't formal standards, at least not yet, but many manufacturers are already running real-world scenarios. In these tests, glazing systems are hit with both gunfire and physical forced entry attempts. The goal is to see how long the system can actually hold up under combined pressure. In schools especially, this kind of testing is critical. Every second that the glazing delays entry gives students and staff more time to move to safety or for law enforcement to respond. It's about survivability, not just strength. Keep in mind, with attacks from gunshots, it's important to realize it's more than just the glass. The entire glazing system must perform. A successful system doesn't just stop bullets. It resists entry even after repeated shots. That's why glazing must remain anchored in place, holding strong to delay threats rather than simply stopping a projectile. In schools, offices, or public spaces, this performance buys time, and those minutes, sometimes even seconds, can make all the difference. Glazing becomes an integral part of safety protocols, helping first responders and security teams do their jobs. Now let's expand from ballistic and intrusion scenarios to another type of threat: blasts. We'll look at how glazing systems are tested to perform when exposed to explosive forces. In some environments, the threat isn't just forced entry or gunfire, it's explosions. Blast resistance testing is critical in places like military bases, embassies, government buildings, and transit hubs. Standards such as ASTM-F 1642 and the UFC anti-terrorism guidelines simulate explosive shock waves to measure how glazing systems respond. The focus isn't only on whether the glass cracks, but on how much debris becomes airborne. The ultimate goal is to minimize fragmentation and ensure that glazing continues to protect the people inside, even in the most extreme conditions. Now that we've looked at blast testing, let's bring it all together and see how these different security glazing strategies and test types help architects, schools, and government facilities make informed choices for real-world protection. When it comes to blast resistance, the biggest danger isn't always the glass breaking. It's the fragments that become airborne and cause injury. That's why most blast-resistant glazing systems use laminated glass with special interlayers, reinforced frames, and flexible anchoring. These components absorb energy, keeping shards from flying into occupied spaces. In the end, it's not just about the glass itself. Performance depends on the entire system design working together to contain the threat. Now that we've explored how security glazing is tested, let's shift focus to the bigger picture: designing for real-world threats. Security glazing is only one piece of the puzzle. To be effective, it has to be integrated into an overall design strategy that accounts for the specific risks a building may face, whether that's forced entry, ballistic attack, or blast. The goal isn't just to stop glass from breaking, but to design environments that protect people and buy time for emergency response. Let's take a closer look at how glazing fits into threat-specific design approaches and why the details matter when we're talking about protecting lives. Of course, not every building faces the same level of risk. A suburban elementary school doesn't need the same glazing solution as a U.S. embassy or a military outpost. The key is to match the glazing system to the specific threat environment. That's where testing and performance standards become so valuable. They allow design teams to make informed decisions. By understanding how glazing performs under different types of attack, you can right-size the solution for each project, ensuring safety without unnecessary cost or over-design. Let's look at how this plays out in practice, tailoring glazing choices to schools, embassies, transit hubs, and beyond. Security testing isn't just a box to check. It's what drives performance-based design. Every standard test gives us insight into how a glazing system behaves when it's under real pressure. That insight helps guide critical choices, not only the type of glass, but also the frame, anchoring, and how the entire system comes together. It validates performance, it supports safety and survivability, and it ensures the system can be specified with confidence. When testing is done right, it leads to safer, more survivable spaces that align with both code requirements and community expectations. Let's wrap up Section 2 with a quick summary of why testing matters so much. First, testing validates real-world performance. It proves that a glazing system can handle the actual threats it was designed for. Second, different tests address different types of threats. Forced entry, burglary, ballistic, and blast testing all serve unique purposes, and no single test covers everything. Third, system integrity is just as important as glass strength. It's not enough for the glass alone to resist impact. The frame, anchoring, and connections all have to hold together. Finally, performance must match the project's risk level. A suburban school doesn't need the same protection as an embassy or a government facility, but every building requires the right balance of safety and practicality. We've seen why testing matters. Now let's look at the materials that have to pass those tests. Section 3 is all about solutions, the types of glazing that are available, how they perform, and how to choose the right system for the job. We'll look at 3 key areas. First, how to choose the right material for the specific threat. Second, how to balance cost, performance, and certification requirements. And third, why it's important to think about system-level performance, not just individual components. This is where design decisions become very real, as every project has its own unique mix of risks, goals, and budgets. So let's begin by looking at how to choose the right material for the threat, because not every project needs the same level of protection. Not all glass is the same, and not every project needs the highest level of protection. The key is to understand the different material options and align them with the risks you're addressing. From basic laminated glass to polycarbonate to hybrid composites, each material has its own balance of strength, weight, cost, and performance. Choosing the right one can mean the difference between overspending on unnecessary protection or underdesigning and leaving occupants vulnerable. So let's start by looking at laminated glass, the most common and widely used material in security glazing. Security glazing is not a one-size-fits-all solution. Different materials perform better depending on the specific threat and project type. The first step in specifying glazing is understanding the risk you're addressing. Is it a forced entry threat? Is it ballistics? Is there a blast requirement? And are we talking about a new school building or a retrofit upgrade? Each of these factors guides your choice, ensuring the glazing solution matches both the performance need and the project goals. Let's take a closer look at laminated glass, one of the most widely used security glazing materials and often the first line of defense. Laminated glass is one of the most widely used security glazing options. It's created by bonding 2 or more sheets of glass with an interlayer, most commonly PVB or ionoplast. What makes laminated glass effective is that even if it cracks under impact, it stays intact. The interlayer holds the pieces together, maintaining a protective barrier. This makes it an excellent choice for schools, storefronts, and office buildings, environments where both safety and day-to-day durability are critical. And laminated glass isn't just about security. It can also be enhanced with coatings for energy efficiency or acoustic control, giving it added value beyond protection. While laminated glass is common and versatile, it's just one option. In higher-risk environments, different materials may be required. Next, let's take a closer look at glass-clad polycarbonate glazing and what makes it uniquely effective in certain situations. Glass-clad polycarbonate combines the best of both materials. Thin layers of glass provide hardness and scratch resistance, while the polycarbonate absorbs energy from blunt impacts or ballistics. It's heavier and more expensive than laminated glass, but it offers superior multi-threat protection. That's why it's often used in courthouses, embassies, and police stations, environments where high security is critical. In short, glass-clad polycarbonate delivers a balance of scratch resistance, ballistic protection, and forced entry resistance, making it one of the most robust glazing solutions available. Window security films are applied to existing glass to help keep shattered pieces together after an impact. They don't stop the glass from breaking, but they can delay entry and reduce the risk of injury. Some systems even anchor the film to the frame, which strengthens performance by keeping everything in place. It's important to remember, though, that window films add retention, not resistance. They are not a replacement for certified security glazing. That said, they are a budget-friendly option, often used in schools and offices as an interim upgrade to improve safety until a more permanent solution can be installed. Now that we've looked at films, let's move to a different type of upgrade: security laminates. These are applied in a similar way, but they're thicker, stronger, and can offer more robust performance than basic films. Here's an important distinction. Window films can help hold broken glass fragments together and may delay entry for a short time, but films are not a replacement for a certified glazing system. In this demo, you can see the difference. On one side, a filmed window fails quickly under impact, while on the other, laminated glass continues to perform as part of a tested system. The takeaway is clear. Films can provide delay, but only laminated glass, tested as part of a complete assembly, delivers real system-level protection. So when we're making design decisions, it's not just about adding a film or temporary measure. It's about choosing the right glazing system for the specific threat. Choosing the right glazing really comes down to one principle: match the material to the threat. For forced entry scenarios, laminated glass is usually sufficient because it stays intact even when cracked. For ballistic threats, you'll need a rated laminated or glass-clad polycarbonate system that's designed to stop bullets. In truly high-risk locations, such as embassies, courthouses, or detention centers, multi-layer systems provide the best protection against multiple threat types. And for retrofit situations, films or polycarbonate panels can be a helpful short-term upgrade, but they should always be seen as interim measures until a full system can be installed. Now that we've outlined how to choose glazing by threat level, let's look at how those choices balance with cost, performance, and certification requirements. One of the biggest mistakes in security glazing is assuming that the glass itself is all that matters. In reality, strong glass alone doesn't guarantee protection. If you place that glass into a weak frame, the entire system can fail. True performance comes from the combination of the glass, the interlayer, the frame, and the anchoring. That's why every component must be tested and specified together. Security glazing isn't just about one product. It's about the performance of the full assembly. Now that we've established why the system matters, let's look at how different system-level certifications ensure real-world performance. Certification is how we know a system actually works. It's not enough to claim performance. Certification means the system has been tested by a third party under standardized conditions. UL 752 confirms ballistic resistance. ASTM F 1233 sets the benchmark for forced entry. NIJ 0108.01 applies to law enforcement scenarios. And EN 356 or EN 1627 are used internationally. Together, these certifications prove that what's specified will actually perform in the field. Certification builds confidence that the glazing system will hold up under real-world threats. Now that we've seen how certification confirms performance, let's connect this back to the bigger picture: why standards matter in guiding safer, smarter design. When it comes time to write the specification, clarity and completeness are critical. The first step is to identify the specific threat, whether that's forced entry, ballistic resistance, or blast protection. Next, make sure the specification references the right standards and any applicable funding requirements, such as school safety grants. Always include third-party test reports and certifications in the documentation. Finally, for public projects especially, aligning the specification with grant criteria can often be the difference between getting approval or not. Now that we've walked through how to specify security glazing, let's step back and connect it to the bigger picture: why these standards and specifications matter in guiding safer, smarter design decisions. Third-party testing and certification companies play a critical role in ensuring glazing systems perform as specified. They conduct forced entry and ballistic testing, verify system performance, and provide the certifications needed for code compliance and funding programs. One example is Intertech. Their experts not only perform the testing, but also help design teams align with grant requirements and specification needs, so systems get installed the right way. So whether it's Intertech or another accredited lab, certification confirms that your design decisions will hold up under real-world threats. When we specify certified glazing systems, we're not just choosing a product, we're ensuring an entire assembly of glass, frame, and anchoring has been tested to perform as one. That certification creates stronger, safer, and more resilient spaces that protect people when it matters most. With the right certified glazing system in place, we can transform buildings into safer environments for students, staff, and communities. Let's recap Section 3. The key to choosing the right glazing is to always match the material to the specific threat. Laminated and glass-clad polycarbonate systems provide true, tested protection, while films and panels can serve as supplemental or temporary solutions but should never replace certified assemblies. And finally, certification confirms that what's specified will perform in real-world conditions. Together, these choices ensure stronger, safer, and more resilient spaces. Now that we've seen how materials and certification shape performance, let's move into Section 4, Real-World Applications, and look at how these systems come to life in actual projects. Welcome to Section 4, Design Integration and Best Practices. This section explores how we design with security glazing in a way that enhances safety while still supporting the educational mission. The goal is to protect students and staff without creating environments that feel restrictive or institutional. We'll look at how to balance safety with aesthetics, create secure spaces that support learning, and see real-world solutions that schools across the country are using today. As we start, let's first look at how architects balance the dual priorities of safety and aesthetics. In schools, security can't come at the expense of learning. Students and teachers need natural light, visual connection, and a sense of openness to thrive. If a space feels like a bunker, it impacts engagement, development, and even mental health. Security glazing allows us to achieve both protection and positivity. Safe doesn't mean sterile. With the right design, we can maintain natural light, openness, and create spaces where comfort and visibility are just as important as safety. Next, let's look at how architects are integrating security glazing in ways that support both safety and aesthetics. The key to great security design is making spaces feel normal, open, and welcoming, while ensuring they're prepared for real threats when needed. Security glazing allows us to maintain transparency, visibility, and daylight, creating an environment that feels safe without feeling restrictive. At the same time, these tested products withstand real-world risks like forced entry or gunfire. The goal is to design for normalcy every day, while being prepared for crisis if it ever occurs. Next, we'll see how these principles translate into school entrances and vestibules, where design, safety, and first impressions all come together. One of the most critical features in modern school security is the secure entry vestibule. This transition space moves visitors from a public area into a controlled private zone. The first set of doors locks behind them before the second set can open, creating a controlled point of entry. Inside this space, staff can conduct screening and manage access without compromising safety. Because these are often the first line of defense, vestibule glazing is tested to resist forced entry, typically meeting ASTM F1233 standards. Now that we've seen how vestibules function as the front line of protection, let's look at other design strategies that integrate safety and learning seamlessly. Inside the building, one of the most overlooked vulnerabilities is vision panels in classroom doors and sidelights. In a lockdown, these glass areas can quickly become weak points. That's why many districts are now using laminated security glass here. Laminated glass can delay intrusion, buying teachers and students critical time to respond. And newer products go even further, meeting both forced entry and ballistic standards to strengthen security inside schools. But classrooms aren't the only place where design plays a role in safety. Let's look at how security glazing can be integrated into everyday learning spaces while still supporting openness and connection. In classrooms, vision panels and sidelights serve an important role in supervision. Teachers and staff need clear lines of sight to keep students safe and engaged during normal operations. But those same openings can become vulnerabilities during a lockdown. That's why schools are incorporating solutions like blinds or switchable privacy glass, giving them the flexibility to instantly block visibility when needed. Security glazing in classrooms balances two critical needs: openness and safety. Now that we've seen how visibility and privacy can work together inside classrooms, let's expand the view to larger learning spaces, where security glazing supports both transparency and strength in design. Most intrusions happen at the ground floor, where classrooms, administrative offices, libraries, and nurse stations are located. These openings are often the most vulnerable access points. That's why they require laminated glass with tested interlayers, securely anchored into the frame, to resist forced entry or impact. When we reinforce these areas, we protect the spaces that matter most in the first seconds of a threat. And as we move beyond entry points, it's just as important to look at the interior spaces, starting with vision panels and glass doors inside the building. Retrofitting older schools presents unique challenges, from limited budgets and outdated windows to older construction methods. Surface-mounted polycarbonate panels or security films can offer a quick boost in performance, but it's important to recognize that these solutions are typically transitional. They provide an extra layer of protection, but most won't meet today's forced entry standards. When possible, retrofits should be seen as a bridge toward long-term, fully certified upgrades. With that in mind, let's take a closer look at how real projects bring these strategies together and what best practices look like in action. While laminated and ballistic rated glazing have higher initial costs, they offer much greater long-term value, reducing repair, replacement, and vandalism expenses while providing consistent safety performance. Retrofit systems can also be significantly less expensive than full replacements, roughly 10 times lower cost, making them viable in budget-constrained schools. Be cautious with window films. Although they're cheaper, they do not stop intruders and are better suited only for temporary delay, not true protection. Let's back up our recommendations with evidence. According to School Construction News and other industry sources, laminated glass is one of the most cost-effective ways to improve security, balancing affordability with durability. A Campus Safety magazine report highlights that retrofitting frames for ballistic glazing can cost about 1/10 of a full replacement, which is critical for budget-conscious schools. And importantly, a Wall Street Journal investigation confirmed that while over $100 million has been spent on window films for schools, these films only delay entry briefly. They do not stop intruders or bullets. This is why true certified glazing systems remain the proven long-term solution. Many schools have access to grant funding for safety upgrades, but those funds often come with strict requirements. To qualify, it's important to align your designs with program guidelines and include proper certification and testing documentation. By planning ahead, schools can maximize these funding opportunities and ensure their upgrades are both affordable and compliant. Now that we've seen how funding programs can support these initiatives, let's look at real-world examples of how schools are integrating security glazing into their designs. During budgeting, it's tempting to cut corners with glazing systems, thinner interlayers, cheaper frames, or eliminating anchoring. But if those changes aren't properly tested, the system can fail when it matters most. That failure means greater liability, failed inspections, and worst of all, the risk of real harm. Always verify that any substitutions meet the same rigorous test standards. Value engineering should never come at the expense of safety. Downgrades may look like savings on paper, but in reality, they translate into liability, failed inspections, and danger when lives are on the line. Now that we've seen why shortcuts can be dangerous, let's look at how Section 4's design strategies keep both safety and functionality intact. Security glazing isn't just an upgrade, it's an essential part of a school's infrastructure. By planning early, specifying complete and tested systems, and designing with performance in mind, we can create environments that feel open and welcoming, but are also built to withstand threats when it matters most. As we wrap up, let's pull together the key lessons we've covered and see how they guide us towards safer, smarter design decisions. Section 4 highlighted how effective design integration balances safety with openness and aesthetics. Security glazing doesn't just protect, it supports learning and well-being by maintaining visibility and natural light. And we saw real-world applications, like secure entry vestibules, interior doors, and retrofit strategies, that demonstrate how these solutions succeed in practice. Now that we've covered best practices in design, let's move to our conclusion, where we'll tie together all the key takeaways and reinforce why certified glazing is essential for creating safer schools. We've discussed standards, design, and best practices. Now, in Section 5, we'll look at real-world case studies that show how these solutions perform in the field. These examples, from vestibules, classrooms, and university labs, will help connect what we've learned to actual conditions, so you can see how security glazing works in practice. Let's begin with our first case study: secure entry vestibules, where performance and design meet at the front door. At this elementary school, a safety audit identified the front vestibule as a top concern. To address the risk, designers retrofitted the entry with ASTM-tested laminated glazing. In a simulated drill, the system withstood a forced entry attack for over 4 minutes, an invaluable buffer of time for staff and first responders. Importantly, the team was able to reuse the existing framing, making this a cost-effective, high-impact upgrade with minimal disruption to the school's operations. This case study shows how smart retrofits can enhance safety quickly and effectively. Next, we'll look at how these solutions apply inside classrooms. At this high school, over 100 classroom door vision panels were identified as a major vulnerability. The old glass provided no real protection. One strike could shatter it instantly. To solve this, designers replaced the panels with ASTM-tested laminated security glass. This upgrade now provides forced entry resistance while still maintaining daylighting and visibility in the classrooms. Most importantly, the laminated panels are now part of the full classroom lockdown strategy, giving teachers valuable extra time to secure their students during an emergency. This case study demonstrates how a simple upgrade, swapping out vulnerable glass for laminated security glazing, can deliver major impact for school safety. This university lab building had a critical vulnerability: ground floor windows facing a busy public sidewalk. To address the risk, the school upgraded to glass-clad polycarbonate, tested to UL 752 Level 3, and ASTM F1233 standards. This glazing stops both forced entry tools and ballistic threats, protecting people inside the building. Importantly, the new system preserved the architectural intent of the campus. The lab remained open and welcoming, while greatly improving safety and resilience. This case study shows how schools and universities can balance strong protection with design goals, even in high-traffic public areas. Together, these case studies highlight how security glazing solutions can be applied across elementary, high school, and university settings, each balancing protection, performance, and design. Now let's move into our final section, where we'll recap the key takeaways and highlight why security glazing is an essential part of safer learning environments. We've covered testing, certification, design, and real-world applications. But as we close, let's focus on the key takeaways. These are the 3 essential lessons you should remember when specifying glazing for safer schools and campuses. Think of them as your roadmap for making the right decisions. Most intrusions begin with broken glass. A door or window is often the first entry point. That's why even a 30-second delay can save lives. Laminated or ballistic rated glazing becomes your first line of defense, slowing down the threat and giving time for response. Not all glazing is created equal. Safety glazing, like tempered or basic laminated glass, meets building codes, but it isn't designed for intentional attacks. Security glazing, such as laminated glass, polycarbonate, or glass-clad polycarbonate, is engineered to withstand repeated impacts, forced entry, and even ballistics. Knowing the difference is critical when specifying. Strong glass alone isn't enough. If it's installed in a weak frame or with poor anchoring, the entire system fails. Always specify glazing as a complete, tested assembly: glass, frame, and anchorage, proven to perform under real-world conditions. Finally, security doesn't mean compromising design. Today's laminated and polycarbonate glazing options provide clarity, light, and protection. They preserve aesthetics while adding critical safety, supporting layered strategies that create beautiful, functional, and secure environments all at once. Thank you for participating in this course on security glazing. We hope you found it valuable in understanding how certified systems can enhance safety without sacrificing design. For additional resources or questions, please contact Isoclima or visit our website.